Hello, Algebra 2 folks, and welcome to Finding X. Okay, we are going to be factoring to find real number solutions. We're going to factor completely and then solve. And we've done this before, but the problems are going to be bigger and there's going to be more x equals. So you are going to factor completely and solve. You need your calculator. You need your factoring tools. And you need your notes. All right, let's get started. All right, key question. How do I use factoring as a way to find the solutions to polynomial equations? Good question. We get our handy dandy toolbox out, okay? And the tools that we need are the factoring tools. How do I greatest common factor? How do I group factor? How do I AC method factor? How do I factor by difference of squares? How do I factor by sum and difference and sum of two cubes? Okay, so those are the questions that you need for today. And the tools that you need. All right, here we go. So once we have those tools, now we can solve any polynomial that we need. So example number 1, you need to write this down. Factor completely and solve. So the first thing we're going to do is we're going to factor. And in order for us to factor, we have to have it set equal to 0. So this problem is set equal to 0. So now I'm going to factor. I need my toolbox of factoring tools. So what kind of factoring do I always do first? I should always do greatest common factoring first. So what do these two have in common? They have a 2 in common and an x cubed. So I'm going to divide out a 2x cubed from each one. So 2x to the 5th divided by 2x cubed would be x squared. Minus 18 divided by 2 would be negative 9. And the x cubes cancel. So that's what I have so far. Well, I'm not done factoring. I need to keep going before I can do the last thing, which is solve. This is the difference of two squares. So I can factor that again. So 2x cubed, bring this down, and now let's factor this. What times what gives me x squared? Well, that's easy, x times x. What times what gives me 9? 3 and 3. One of them is a positive and one of them is a negative. Now that I have completely factored it, I can take and solve, which means I can use the product property rule, which basically says I can take every factor and set it equal to 0 and solve for x. So 2x cubed equals 0. Okay, divide both sides by 2. X cubed equals 0. The opposite of cubing is cube rooting. So I'm going to cube root both sides. Well, 0, cube root of 0 is just 0. So x equals 0 here. Okay. Then I can take and set this equal to 0, which is x plus 3 equals 0. Well, x is going to be negative 3. And I can set that equal to 0. And x would be 3. Now, what I should have is I should have as many solutions as my largest degree. So if my degree is 5, in this case, I should have 5 solutions. I'm only seeing 3 here. That's a problem. Well, guess what? Here's 1, here's 2, and there were 3 zeros. So we do have 5 solutions, we just don't see it. So we have a 0 3 times, okay? And I can write that 3 times, okay? Or I can write 0 and I can write triple root, okay? That means 3 times, okay? And then I have negative 3 and 3. But I should have as many solutions as my highest power, or my degree. Okay? So I can write 0, 0, 0, negative 3, 3, or 0 triple root, TR means triple root, negative 3, 3. And those would be my answers. Okay, let's do another one. Factor completely and solve. Okay, let's look at the power. How many solutions should I have in this one? The largest power is 3, so the degree is 3, so I should have 3 solutions. All right, so what kind of factoring am I going to use here? Well, first and foremost, I should always make sure that there's nothing in common. I don't see anything in common. And now I go through my toolbox. Do I have 3 terms? If I don't have 3 terms, I can't use the AC method. If I don't have 2 terms, then I can't use the sum and difference of 2 cubes or the difference of 2 squares. I have 4 terms. 4 terms means I have to use grouping. Okay, and so I'm going to draw my squares, put all my terms in my squares, and then I'm going to factor row by row, column by column. First row, x squared. Second row, negative 16. First column, x. Second column, negative 3. So I have x minus 3 and x squared minus 16. Okay, so now what I'm going to do is I'm going to make sure that nothing else can be factored. Well, if I'm down to a power of 1, that cannot be factored any further. This one has an x squared, so I'm going to look at it and go, okay, can I factor it? Well, it doesn't have anything in common. It doesn't have 4 terms. It doesn't have 3 terms. Oh, it has 2 terms. So my 2 terms, are they squares or cubes? 16 is a square. X squared is a square. So this is the difference of 2 squares. So I can factor one more time, bring down the factor that's already done, and then factor the second part. What times what gives me x squared? That's x and x. What times what gives me 16? That's 4 and 4. One is positive and one is negative. I have 3 factors. Now I can use the zero product property rule. I can set each factor equal to 0, and I get 3, and I get 4, and I get negative 4. And how many solutions should we have had here? We should have had 3, and we do have 3. They can be written in any order. Okay, let's do another one. Factor completely and solve. Again, we always want to make sure it's set equal to 0 before we do any factoring. Okay, I have 3 terms here. Oh, that's kind of scary. The first thing I should do is probably make sure that there's nothing in common. Okay, and how many solutions should I get when I'm all done? I have a degree of 3, so I should get 3 solutions. So the first thing I'm going to do is see if they have anything in common. X cubed, negative 4x squared minus 12x, they all have an x in common. So I'm going to take an x out. When I divide out an x, I get x squared minus 4x minus 12 equals 0. Okay, so I've got an x out. Now I want to make sure that I can't factor that any further. It probably looks like I can. There's 3 terms, so the second type is going to be using the AC method. All right, 1 times negative 12 is negative 12. 2 factors of negative 12 that give me negative 4 would be negative 6 and positive 2. Rewrite this as a 4-term problem, okay, and then use my squares. So x squared, negative 6x, 2x, and negative 12. First row, x. Second row, 2. First column, x. Second row, negative, or second column, negative 6. So my factors are x plus 2 and x minus 6, and this x that I had originally taken out a long time ago. So now that it's factored completely, I can use the zero product property rule. I can set each factor equal to 0. So x equals 0, X plus 2 equals 0, that's negative 2. And x minus 6 equals 0, that would be x is 6. How many solutions did we have to have? 3. How many do we have? We have 3. 0, negative 2, and 6. Okay, let's do one more. Factor completely and solve. Okay, this time it's not set equal to 0. So I got to get everything on one side. So 2x to the 5th, I'm going to subtract 14x cubed from both sides, minus 14x cubed. I'm going to make sure it's in standard form. That's why standard form is so important. Largest degree all the way down to the smallest. Okay, so now that I have it set equal to 0, now I can factor. First type of factoring I always want to check is greatest common factoring. Do they have anything in common? Yes, they do. They have a 2x in common. So I'm going to take a 2x out of each and every one of them. I will get x to the 4th minus 7x squared plus 12. Okay, now I'm going to see if I can factor this further. Well, it looks like it's in quadratic form, and there's 3 terms, and this is a 4, and 2 is half of 4, so it looks like I can use the AC method on this trinomial. 1 times 12 is 12. 2 factors of 12 that give me negative 7 would be negative 3 and negative 4. Okay, then I can make my squares. X to the 4th. Remember, if you need to, rewrite it as a 4-term problem. X to the 4th minus 3x. This one has to be a squared now, because if the middle term is squared, this has to be squared. Minus 4x squared plus 12. If you need to do that step, go ahead and do that. Make sure that these are squareds, though, because the middle term is squared. So first row has an x squared in common. Second row has a negative 4 in common. First column has an x squared in common, and then second column has a negative 3 in common. So I'll have x squared minus 4, x squared minus 3, and then the 2x that is out in front. Okay, now I'm going to make sure that I can't factor anymore. So 2x can't be factored anymore. Oh, x squared minus 4. That looks like that could be the difference of 2 squares. Oh, goodness sakes. So we're going to take x squared minus 4 and factor it further. Okay, so how do we factor x squared minus 4? Well, that would be x and x, and then 4, square root of 4 is 2 and 2. One's positive, one's negative. Okay. Oops, x squared. Oops, I need to get my eraser here. Sorry about that. This should be x squared minus 3. And I cannot factor that because 3 is not a perfect square. So those are my factors. Now I can set each factor equal to 0 and solve. How many solutions should I get? I should get 5. Okay, let's see if we get 5. Take our first factor, 2x, and set it equal to 0. Divide by 2. X is going to be 0. So there's one solution. Then take x minus 2 and set that equal to 0, and x will equal 2. There's another solution. Then take x plus 2, set that equal to 0, and x will be negative 2. There's another solution. Now we're going to take x squared minus 3 and set it equal to 0. Add 3 to both sides, and then square root. And remember, when we square root, we always need a plus or minus. Yay! So we did get 5 answers. Awesome. Because plus or minus the square root of 3 would be 2. And then we've got the other 3 for a total of 5 solutions. Awesome. So that's all, folks. Remember tomorrow when you come in to bring in your factoring toolbox so that we can solve these polynomials. Have a great night. I'll see you tomorrow.